So far in this course, we've talked about the technical aspects of deploying a web page. We've talked about programming and using databases. In this lecture and the next few lectures, we're going to look at some of the non-technical aspects of deploying a successful website. And we're going to start in this lecture by talking about site administration and maintenance. So what is site administration? Site administration tasks are tasks that involve deploying and maintaining a web page that's available and accessible. So that includes several different tasks. For one thing, we have to set up the web server and any database software that we need. If we're going to be running scripts on the server, we also have to configure any programming languages that we need to run those scripts. We also need to know what's happening on the website. And to understand what's happening on the website, we look at server logs. The server logs can tell us things about who is visiting our website and whether something has gone wrong so that we can fix any problems that occur. We also need to conduct regular backups of the server so that we don't lose information in case something happens. And we also have to take some steps to make sure that the web page is public. And that involves obtaining an IP address, obtaining a domain name so that users can find our web page, and also getting the page into search engines. So we're going to talk about all of those things in this lecture. Let's start by talking about setting up a web server. Now, there are a lot of different approaches to this today. It used to be that really your only approach was to set up a standalone server. You would buy a computer from Dell or Compaq or from IBM, and it was usually a bare metal server. In other words, it came with just the hardware and maybe an operating system, and any other software that you wanted to set up, you had to install yourself. And websites still do that today. Some of the big websites have their own hardware that they configure. There's a couple different approaches to this that have become popular, and they're known by some really important to remember acronyms. One is LAMP. If you hear someone talking about LAMP or the LAMP stack, what they're talking about is a particular configuration of a web server. LAMP stands for Linux, running Apache, and MySQL with PHP. So you have a Linux operating system. Running on that Linux operating system, you have the Apache web server. On top of Apache, or running alongside Apache, you have a MySQL database. And gluing them together, you have a PHP interpreter that can interpret scripts. Another approach is LAP, L-A-P-P. This is similar. This is Linux and Apache with Postgres and usually PHP or Python. So LAP is an alternative to LAMP that's popular in the Postgres community. You may hear the term WAMP. WAMP is like a LAMP stack, except that instead of using Linux, you use Windows. So it's Windows with Apache, MySQL, and PHP. These are really popular configurations for a website. Of course, there are others. You could use a content management framework like Ruby on Rails, or Python Pyramid, or Django. There's a whole bunch of different ones that you have probably heard of that are used in popular websites. Another approach is not to buy physical hardware and configure it directly, but instead to use virtual servers. So you may have a computer that already is running some other kind of system, or maybe it's just an old system sitting in a closet that you want to reuse. You install an operating system on it, and then you also install some sort of virtual machine. And a virtual machine is exactly what it sounds like. It's a program that pretends to be a hardware device. It pretends to be a computer, and it emulates the assembly code instructions that a computer would run in order to launch software. And using virtual machines, we can create virtual servers. There are lots of different software for doing virtual servers. VMware is very popular, although also expensive. Oracle bought Sun Microsystems, which created a virtual machine named VirtualBox. There are also a bunch of free and open source virtual machines. Probably the most popular of those is Camus, sometimes also called KVM, which I think is based on something called Box, which is no longer available. One of the really neat pieces of software that's out there is something called Proxmox. Proxmox lets you create virtual machines and manage them through a web interface. So it's a virtual machine management tool, and it's really powerful. And Proxmox is actually based on Camus. So you can use Camus virtual machines or Linux containers, which we'll talk about in a minute, within Proxmox, and you can easily spin them up and spin them down. This is really neat. Another approach is to use containers. Containers are like virtual machines in that you can run software and keep it separate from the other operating system programs that are running. So I can run 2 different servers on the same machine, and they can't interact with each other in any way. This is really good for security. But unlike a virtual machine, there's no emulation. Software that's running in a container is actually running on the same operating system. It's running on the hardware. So there's no layer in between translating virtual instructions to real instructions. That's really, really neat because it means that containers tend to run really fast and they have really good performance. The downside is that you have to run the same operating system in all your containers. So with a virtual machine, I could run Linux on a Windows computer, or I could run Windows on a Linux computer. With containers, I'm pretty much running Linux. So I have to run the same set of software in all my containers. Containers, like I said, are becoming very popular. The most popular solutions for containers are Docker, LXC or Linux containers, and OpenVZ. Proxmox, I think, actually provides OpenVZ, but I think they may have moved to LXC. At any rate, Proxmox allows you to use either a Camus virtual machine or a container. A fourth approach is to use cloud services. And there's a couple different levels at which you can access virtual machines in the cloud. So one level is called infrastructure as a service. Essentially what this means is that Google or Amazon or some other provider will set up a bunch of servers for you, and you can log into them and install whatever operating system you want. So you have access to that system as if it were a physical machine. The only difference is you don't have to worry about maintaining the hardware. Another step up from that is platform as a service, or PaaS. Platform as a service gives you a little bit more than infrastructure as a service. In addition to maintaining the hardware, the cloud provider is also maintaining the operating system. And so you can log in to a virtual machine that's already been deployed for you. You can install whatever software you need, and you're up and running. At a higher level is software as a service, where the cloud provider provides not only the operating system, but also the web server or other software that you need. It's already set up and configured for you. And they provide some sort of API, or application programming interface, that allows you to log in and use their services. So for example, Google Maps is a good example of software as a service. You can use the Google Maps server without configuring an operating system and deploying all these resources. You just make calls from your Python script to their server, and it does whatever you ask it to. So there are lots of different cloud providers competing in this space. AWS is probably the most popular right now, but Google Cloud and Rackspace are close behind. Microsoft has something called Azure. And if you want to build your own cloud infrastructure, you can. There's something called OpenStack that will let you install software on a couple physical systems and provide your own cloud service. So once you've set up your operating system and your hardware, it's time to start installing software. And if you're using Fedora Linux, you can do that with the DNF command. So for example, to install the Apache web server, I would say DNF install Apache 2. If I want to install the Nginx server, I would say DNF install Nginx. On Debian-based operating systems like Ubuntu and Mint, and of course Debian itself, I use the apt command. I can say apt install Apache 2. If you look on the web, you may see some sites and tutorials that say apt-get install. That's the old way of doing it. Apt is the new tool, so you don't need apt-get anymore. You could, of course, also use containers. If you want to use, say, a Docker container, that's actually really easy. You just install Docker on your computer, and you type the command docker pull and the name of the particular image that you want to install. So here I can install a complete LAMP image, a Linux Apache MySQL PHP stack, by saying docker pull linode/lamp, and then I can run the container with the docker run command. In this case, I'm mapping port 80 to port 80. So port 80 in my container, which is the HTTP port for web service, will actually be publicly visible. If someone connects to my container host on port 80, they'll get this particular Docker container. You also need to configure the web server. So Apache is one of the options. It's one of the most popular web servers available. Apache allows you to create several different virtual hosts. What does that mean? That means that on one server, one virtual machine or one physical machine, I can actually support several different web pages with different names, and they can be configured differently and serve a different set of pages. For example, on my server at home, I have several websites that I maintain. One is my personal web page, marmerstein.org. But another one is a web page for my church, stjohnsfarmville.org. And so here is a configuration for stjohnsfarmville.org. I tell it that this is a virtual host, and no matter what the name is, that's what the star stands for, if a connection comes in on port 80, I should tell it that the server name is stjohnsfarmville.org, or if it comes in for a server named www.stjohnsfarmville.org, that these rules should apply. The document root command tells it where to look for web pages. So it's going to look for index.html, for example, in /var/www/stjohnsfarmville.org/htdocs. I can also then configure options for that web page. So I have a directory and a /directory tag here that say all the files under var www.stjohnsfarmville.org should be treated using these options. First of all, I turn on some options. So indexes are enabled, which means that if they go to a folder on my website that doesn't have an index.html, it will give them a list of all the files in that folder. It follows symbolic links. It allows me to do server-side includes, which, by the way, are dangerous and a security vulnerability, but I have them very restricted on this site. And then it tells them that they can exec CGI scripts, which you've been learning to write. Then I say, OK, require all granted. That basically gives any user permission to visit my site. If I wanted to restrict access to specific users who've typed in a username and password, I could do that here instead. You also need to create users on your server so that developers can log in and edit their web pages, maybe using Vim. So in Linux, to create a user, you use the user add command. It's really important that you add the -m flag, which makes a home directory for that user. So user add -m, and then the username creates a user. To delete a user, we use the user del command, and -r removes the home directory and any other files that that user's created. And then we can set a password for that user with the passwd command. I said that setting up the server and configuring it was one important task that a site administrator is responsible for. Another is analyzing logs. So most web servers store logs in plain text files somewhere on the hard drive of the server. Apache stores its logs in one of two places. On some Linux distributions, it puts them in var log Apache 2. On others, it puts them in var log HTTPD. It matters whether you're on a Fedora-based system or a Debian-based system, whether you're on Arch Linux. But if you look in both of these places, you'll eventually find your logs. There are really three important log files that it creates. It creates a file named error log, a file named access log, and a file named suexec log. It also creates variants of these for both HTTP and HTTPS connections. The error messages for HTTPS connections go into a file named SSL_error log, SSL_access log, and so forth. The error log is where the server places connection error messages. So if someone tries to pull up a web page and that page doesn't exist, we're going to see that in the error log file. The access log keeps a list of all pages that have been visited by any IP address, and it tells me what system accessed which web page on my server, whether it was successful or not, and also how many bytes were transferred. This is really useful for auditing. suexec log is where we store errors from CGI scripts and other executables. So for example, if I'm running a Python script and there's a syntax error, it'll show up in the suexec log. It may also show up in the console. So if you've been trying to debug your projects, you should look at the command line first and see if it printed an error message. And if it didn't, then you can go look at suexec.log in one of these two folders. So this is what error log might look like. These are actual error messages from my server. The first error message says authorization result of require any granted. In other words, it allowed someone to connect to one of my pages that required authorization. And it tells me that this was from a system with the IP address 66.249.79.26 from port 51921. That's actually not very meaningful because port numbers are basically randomly generated on the client. The second error message says that someone tried to access a page that they couldn't find. var www.owncloud.marmerstein.org htdocs owncloud index.php. They are looking for an owncloud setup that doesn't actually exist on my server. So this was probably an attacker trying to break into my system by looking for vulnerable pages. And then a similar error message, var www.stjohnsfarmville.org htdocs wplogin.php not found or unable to stat. WP probably stands for WordPress. It looks like someone is scanning, looking for a vulnerable WordPress installation. It doesn't look like they got in because I don't have WordPress installed there. The access log file looks a little bit like this. Notice that on the left, they have each of these entries has an IP address. That tells me which system was connecting. I could then go look that up with GeoIP or something to see where they're connecting from. Of course, IP addresses can be spoofed, so it's fairly likely that if I'm getting attacked, that these are either spoofed addresses or they are from some infected system. You know, someone got a virus and now their system is attacking my web server. But at least it gives me some information about where connections are coming from. It also has a date. It tells me when this access happened. So this access happened on December 7th of 2017 at 1:09 p.m., which wasn't very long ago from when I'm recording this. It was a GET request for the root of my web server, and it was an HTTP 1.1 request. When they requested that, they got an error 301. If you go back to the first lecture and look at the HTTP status messages, you'll see that 301 is what the server returns when it wants the browser to know that something has moved permanently. So there is no /URL here. It's actually /index.html or something like that, and Apache is redirecting them. The last number is the number of bytes transmitted, so that redirect message only took 307 bytes. If we scan through this a little bit further, we can see a bunch of requests for that root web page, all from the same client, which is a little unusual. And then we have a request for a picture, a pharaoh.jpg picture, and it has status 200, so that was successful. They actually downloaded that picture. Notice that that's from a different IP address that also downloaded a different picture, a picture of my church picnic. The bottom request looks a little suspicious. Notice the $P equals. That's part of a query string in a URL. That's often used to do SQL injection attacks. So they were trying to break into a database possibly. That looks like another attack. Another task that a system administrator needs to do is to perform regular backups. There are a lot of different things we might want to back up. The most important thing to back up is the actual text of our web page, the HTML files, the CSS, all those scripts that we've been writing. Those are usually stored in var www. On some systems, they're stored in srv www, and on some systems, they're stored in serve HTTP. It's also important to back up configuration files in any databases that we have. Those are usually stored in these two directories, the etc directory and either varlib or varspool. There are lots of different ways we could do the backup. We could do file system snapshots. If we have a file system like ZFS, the file system, the operating system actually has built in a way to basically clone the entire hard drive. And so we can use snapshots to do that. If your file system doesn't support that, you can use something called Logical Volume Management, or LVM, that adds those features to existing file systems. A better approach is to store your backups on external media. Rather than making a copy on the same hard drive, which might fail, and then you would lose not only your files but also your backup, we can put them on, say, a DVD, or we could roll them off to tape, or maybe copy them to another server. And two of the commands that we might use for that are the tar command, which you've been using to turn in your projects, and also the rsync command, which is really neat. It'll copy files from one folder to another, or from one system to another over a network, and it will make sure that if you're copying multiple files, that if a file has already been copied, that it doesn't copy it again unless it's changed. So it only copies files that have changed, and that's great because that means we don't have to wait for long downloads. It'll just loop through all the files on each computer, and if I've modified something, it'll copy just the change. We can do a backup over a network using one of these two tools or several other tools that are available. We can also back things up to the cloud. So Amazon, for example, provides Glacier, which is a service for long-term storage. It's really useful for backing these things up. A lot of other companies provide that. I think Dell has something. There's Carbonite. You're probably familiar with a lot of these different services. We want backups to be regular, and instead of having to remember to do them each week, it's good to automate that. There's a tool called cron that will allow us to run a script once every week, or once every day, or once every hour even. And so we can use cron to schedule a tar command or an rsync command to back up our website regularly. One of the most important tasks is obtaining a public IP address. IP addresses are managed by a nonprofit organization called IANA, the Internet Authority on Names and Addresses. They're allocated in blocks called subnets to different internet service providers. And some of the ISPs are Tier 1 ISPs that are directly connected to the internet backbone. And then Tier 2 ISPs purchase internet service from Tier 1 providers and so forth. And so there's your local ISP, like Comcast or whatever, is probably buying internet from another company like Hurricane Electric or Level 3 Networks or something like that. You can get an IP address either as a static IP address that doesn't change, or using a protocol called DHCP, Dynamic Host Control Protocol, that contacts a server when you boot your computer and says, hey, what is my IP address? The server replies and gives you an IP address, and then you use that. The problem with DHCP is that sometimes addresses change. When that happens, users won't be able to find your website anymore unless they know the new address. We'll talk a little bit about how we can solve that in a minute. Something else that's important is called network address translation. Network address translation maps ports on a public router or a public gateway to ports on a private server. So for example, if you have a wireless router at your home, your internet connection probably goes through that wireless router, and your laptop or any other device probably connects to that wireless router instead of directly connecting to the internet. If people want to access your web page, when they go to your IP address, they're going to get your wireless router, not your system. So if you want to forward their traffic through from the router, you have to use NAT, Network Address Translation. Or you could just use a cloud service, and all of this is done for you. Yay, virtual machines. One of the important things to consider when choosing an internet service provider is a hosting management agreement. Hosting management agreement tells who is responsible for what. So you need to think about security. Are you going to be responsible for security? Is the provider going to be responsible for security? Normally, the website owner is responsible for security unless there's a specific clause in the hosting agreement. So many hosting companies have some degree of security on incoming traffic. They have a firewall that blocks known malicious traffic. But they usually don't have any security on outgoing traffic. So if you get compromised and someone takes over your server and starts sending spam or something out, you could be in a lot of trouble. So you need to make sure that you've considered that. Configuration control is also important. Configuring your website and being able to log in and make adjustments to the configuration is usually the website owner's responsibility. And you need to read the hosting management agreement and make sure you understand the hosting company's policy on how that works and what options you have to set up. Bandwidth availability is another thing to consider. There's usually some sort of minimum guarantee in the hosting agreement, and you can often pay for better service that provides more bandwidth. If you're not getting, say 10 megabits or a gigabit or whatever that you think you agreed to, it can be really hard to prove that because there's a lot of other factors at play. The speed of your software or your database, for example, can be the limiting factor instead of the speed of the network connection to your host. So be careful with that. Shop around, try different ISPs. Obtaining a domain name is also part of a system administrator's task. There are two parts to obtaining a domain name. First, you have to register the name. Registering the name reserves it so that nobody else can use it. Second, you have to actually map it to your IP address so that when people type in www.example.com, they get your web page. To obtain a domain name, you go through a company called a domain registrar. DIN.com and GoDaddy.com are two of those, but there are hundreds. They're regulated, again, through IANA and ICANN. Both of these steps cost money. You have to pay money to reserve the name, and you have to pay money to actually map it to an IP address. And they're not that expensive, but they have to be renewed typically once a year or once every 5 years. The exact nature of the contract differs. A lot of these services provide some sort of discount for doing a multi-year reservation. Another option is to use dynamic DNS. Dynamic DNS is useful if you're using DHCP, where you might not be getting the same IP address all the time. Basically, the way that dynamic DNS works is that your DNS registrar will allow you to run a script on your server that will detect changes to your IP address and automatically update the mapping in their database. It usually takes an hour or two for that change to propagate across the internet, so it's possible that service will be interrupted a little bit after the IP address changes. So static IPs are still better, but this is an option if you only have access to dynamic IPs. There are different types of DNS records that you might need to configure. An A record or address record stores an IPv4 address, which is a 32-bit address that you're probably familiar with, like 159.230.226.130. There's also something called a quadruple A record, AAAA. These are used for the new version of the internet, for Internet Protocol version 6 that's come out. It's widely used in Asia, not so widely used in the States right now, although I think Time Warner and Comcast are using these on some of their cable systems. It stores a 128-bit IP address, which means that there are a lot more IP addresses available, and we're not going to run out like we did with 32-bit addresses. A text record is a way to store a comment in the database. A lot of services are abusing this to store things like signing keys. And there's something called Sender Protection Framework that is designed to prevent spam. The idea is that your email server will store a key in a text record in the DNS entry, and when Gmail or Verizon or whoever your email provider is receives an email from you, they actually check the DNS table and see if that key matches. And if it doesn't, then they assume that the message is spam. This is causing a lot of problems in the network. I'm not going to rant about it right now, but you should look up Sender Protection Framework and you can read more about that. If you already have one host that's mapped to an IP address and you want to map a different virtual host to that same IP address, you can use a CNAME record. A CNAME record just creates an alias for a website, so you can map one domain to a different domain name. So for example, I have mapped stjohnsfarmville.org to marmerstein.org, and that way if the IP address for my server changes, I just change it for marmerstein.org, and it automatically updates all the other websites that I'm hosting. Finally, an MX record is used to store the address of an email server. The web and email are kept separate in the DNS system because I might want email for a particular site to go to a different server than the one that's hosting the web pages. To register a domain, you're going to have to fill out something called Whois information. This is basically a registration form that asks you for your name and address and contact information. The idea here is that if you have a public website and it's being used maliciously, the engineers who run the internet, they need to be able to contact you to say, hey, something's wrong. So if I'm running a website and somebody else is running a website and they're getting attacked from my site, they can contact me and say, hey, you need to do something with your server. Unfortunately, all of this information is made publicly available, and anybody can run a Whois command or go to a website that lists Whois information and look this up. And then that can be used to figure out who you are and try to send you phishing emails or to attack your network in other ways. So there's a trend, which is not to register your website directly, but to register it through a special company called a domain proxy that registers it for you and puts their contact information in. And then if someone needs to contact you, they contact you through the proxy. And that keeps your personal information safe. Costs money, but it's usually worth it. Something to keep in mind is that domain registrations do expire. They're only valid for a certain period of time, maybe 1 year, maybe 5 years. And as soon as they expire, pretty much anybody else can grab that domain. So there are attackers called cyber squatters that watch for that. They find domains that are popular but are close to expiring, and as soon as they expire, they try to register that name and kind of hold it hostage so that you have to pay them money to get it back. And they can charge you $1,000 or more to recover that domain if it's really popular. Another thing that is really common is what's called typo squatting. The idea is that if I go to Amazon.com, I'm fairly likely to typo, and so I might get Amazon.com and leave out an A, for example. So if I register a website that looks like Amazon.com but is slightly misspelled, when people typo the name of the website, they'll get my site instead, and then I can sell them my product, or I can try to scam them in some way, or I can even make them think that I'm Amazon, and when they put their credit card information in, then I can steal their identity. So typo squatting is something that you need to be worried about. It's usually a good idea to register not just one domain name, but lots of similar domain names. A really kind of funny example of this is that in the early days of the internet, there was a porn website that registered whitehouse.com. So a lot of people went to whitehouse.com thinking it was the White House, but the White House is actually at whitehouse.gov. And so they would get this porn website instead, which was not fun, especially if you were on, say, a school network with a policy about that. It turns out it might be a lot easier to actually pay the ransom for cyber squatting than changing the business to a new domain name. Because you could, if you've got established customers that are going to your old website, you could lose a lot of money. If you want traffic on your website, it's really important to be indexed in a search engine. Engines like Google and Yahoo, they index pages using something called a bot. A bot is just a script, a program, that browses the web. And when it sees a page, it finds all the links in that page and visits them too. And it keeps doing that, looking for keywords and other information about the page, such as how many links there are to a page and how many links there are from a page, so that it can put them in the proper place in the database that the search engine uses. So it scans the web page, it extracts keywords, it analyzes links to and from the page, and then it adds the page to an index. you can control how bots visit your site using a robots.txt file. If you create a file named robots.txt and put it in a publicly accessible folder, like your public HTML folder, you can say, okay, bots, these are the pages that you can look at, but don't look at these because they require a password and you don't want to see all that stuff anyway. And so the way that works is you say user agent : and then some pattern that tells it which bots to apply this to. If you want to apply it to all bots, which you probably do, you just say star, user agent star. And then you can say disallow : and give it the path to the part of the website you don't want it to see. So disallow /secret, and the bot will ignore that. Search engines have to make a judgment call about which sites to list first in the search results. It can be really important to be ranked high in the search results so that if someone searches for whatever your business sells, they find your site first and not some other competitor. The process of setting up your site so that you're likely to be ranked well in the search results is called search engine optimization, or SEO. It's a huge industry. There are a lot of people who do this for a living. They go to websites and they modify the HTML and edit the robots.txt file and do other kinds of things to make a site friendlier to the bots so that you're more likely to get a good score and be indexed way up in the search listing. Entrepreneur.com has a list of some things that you can do to improve this, and here are some of the things that they suggest. They suggest focus on a particular keyword or phrase, and put that keyword in the page title, in the headers of your page, in alt text for your images, and also in your URL. Research the competition and see what they're doing with their web pages and imitate that. Make sure that your pages link to each other, because some of the search engines use how many links there are to a page as part of the score. Don't go too overboard with that, because they penalize you if it looks like you're trying to game the system. And also post your link on other web pages, so advertise yourself. So you can read more about that on entrepreneur.com. Another thing that's really important to consider is security. And security depends on using what we call digitally signed certificates. So there's a technology called SSL or TLS, which stands for Secure Socket Layer and Transaction Layer Security. Transaction Layer Security actually is the new version. SSL is the old version. And TLS provides two different services. First, it provides encryption. So if you're typing in a password or a credit card number on a website, if it's protected with HTTPS, with Transaction Layer Security, then that information is not transmitted in plain text where anybody can see it. It's actually encrypted. It also provides what's called validation or verification. That basically proves that your website is the real website, that somebody isn't spoofing it. For example, suppose that I go to a hotel. When I try to connect to their wireless, I often connect through something called a captive portal. You've probably seen these. It's a page that intercepts what you were trying to connect to, and it comes up and it says, you need to agree to these terms of service to get on the wireless network here. It's very easy for someone to put up a fake captive portal, and when you log in, they connect you to the wireless network by going through the real captive portal, but in the meantime, they're spying on your connection. They're snooping your packets. You want to make sure that anything that you send that way is encrypted. It's even better if we know that that fake captive portal isn't the real one, because we're using certificates, and the certificates don't match because it's an imposter. So in order to do this, we have to have digitally signed certificates. We have to use public key encryption. These are issued by a trusted third party called the Certificate Authority. So some of the popular certificate authorities are VeriSign and Thought. There's one called CertBot or Let's Encrypt that's a free service that's really neat. But they're also, they also provide certificates that prove that they are a valid certificate authority. And those certificates are usually distributed with your web browser. When you download Firefox or Chrome or Brave, it comes with a set of certificates so that it knows who the certificate authorities are. It then checks the certificate authority to see if it's valid, and if it's valid, it can check the certificate for the website you visited. Certificates can be revoked for several reasons. Financial reasons. Certificates cost about $1,000 a year for most authorities, and so if you don't pay your fee for the year, you can get your certificates revoked. And then when people visit your webpage, it will say, it's not the real webpage, danger, danger, and it won't show your website. A compromise of the chain of trust between the CA and a certificate holder. So if you own a website, you're the certificate holder, and if your certificate isn't certified by somebody that the browser knows about, then it's not going to work. If the website changes ownership or management, the certificate authority might revoke the certificate until they can validate that they are the right website and the real owners. A new management may not want old certificates in play because they have outdated information. So they might issue new certificates and then they have to be refreshed. But the most common reason that certificates expire is that you forget to renew them. So that's a really important job for a site administrator, to make sure that the certificates get renewed. I mentioned before that certificates are expensive. There is a free alternative, and it's called Let's Encrypt. Let's Encrypt is a nonprofit organization connected with the EFF, the Electronic Frontier Foundation. The goal is to get more people using secure websites by providing free certificates. So Let's Encrypt and CertBot allow you to obtain certificates for free. They're not as secure as a commercial one because Let's Encrypt doesn't do any verification that you are who you say you are, really. Anybody who applies for a certificate gets one. But it's better than nothing, especially if all you want the certificate for is encrypting information like passwords and credit card information. Certificates contain information that's specified in the certificate signing request, a common name, which is the domain name of your server, www.example.com, the name of your organization, the organizational unit, like which department controls that particular website, the city that you're in, the state that you're in, and the country that you're in. So to generate a certificate, we can use different Linux tools. One is called OpenSSL. To create a certificate, you have to go through a series of steps. The first thing you have to do is create a cryptographic key pair. So we can use the OpenSSL genRSA command to create a private key and a public key. We can then export the public key with OpenSSL RSA command. Then we can sign a certificate or create what's called the certificate signing request with OpenSSL REQ. And then once we've generated that request, we can send the certificate request file to a certificate authority, and they will send back a signed certificate that we can deploy on our website by putting it in the appropriate folder. That's usually etc/SSL on most modern Linux systems. A couple other distributions put it under the web server configuration. Another aspect of site administration and maintenance is testing. I want to thank Dr. Daryl Carpenter for sharing some of these materials with me, because he's really an expert in this area. So there's actually 4 different layers of web development, and we've talked about all 4 of these. First, there's the data layer. The data layer is where the HTML and CSS code goes. You can't create an effective website without some content. So that's in the data layer. On top of the data layer, we have the structure layer. This is what organizes the information, breaks it into parts, provides headers for the page sections, and so forth. And HTML takes care of organizing that content. The design layer is where we have our CSS that makes it look nice. And finally, on top of that, we have the behavioral layer. This is where our scripts are, our JavaScript, our Python, our AJAX. We have to test all of those layers. We have to test the data layer to make sure the content is correct and that it's spelled correctly and things like that. We have to test the structure layer to make sure that we aren't missing tags and that all of our links work properly. We have to test the CSS layer to make sure that the website looks correct, not just on one web browser, but on many different web browsers and on different devices. And finally, we have to test the behavioral layer, because we need to make sure that our scripts work on all platforms and don't break. So we have to do different kinds of testing, and 4 of the most important kinds of testing are functionality testing, compatibility testing, usability testing, and quality assurance testing. So functionality testing is designed to make sure the website works properly in the operational environment. And there's 2 different approaches to this that we're going to talk about, actually maybe 3. The first is unit testing. The idea behind unit testing is that we can break the site into small pieces and test each one. So maybe I'm going to test just my login page. And I'll do a bunch of tests on just my login page. And then I've got some sort of report page, and I'll test just the report page. And unit testing tests each component of the website in isolation by itself, without thinking about its interactions with the other components. Smoke testing is sort of like a pre-testing phase. It makes sure that all of the components load and run. So it's sort of your baseline. You start with smoke testing to make sure that everything is up and running. So do things run? Do they connect to each other? Does the web form connect to the database? Does the database connect to the Python script? And do they have basic operating capability? Integration testing is also important. Integration testing makes sure that all of the connected components work together to complete your business objectives. You could do this with unit testing, except that unit testing only tests each component. It doesn't test the connections between them. So we have to also do integration testing to make sure that the pieces communicate with each other. If we had perfect unit tests that tested everything, we might not need integration testing, because if each part works, then the whole is going to work. But in practice, we can't do that, so we need both. It's also important to test your website for performance to make sure that it isn't too slow. So we can do soak testing, which is a form of load testing. And the idea here is you just hammer your system. You generate, probably using a script, a whole bunch of requests to see how it responds. Make sure it doesn't go down under a heavy load. You need to plan for a lot more traffic than you expect initially, because you might get a flash crash or something, and you don't want your site to go down when you need it most. After you've found a bug and fixed it, you need to do regression testing to make sure that the change that you made doesn't break anything. So in addition to unit testing and integration testing and load testing, we need to do all of these things. We need to run the tests again and again and again anytime we make a change. Compatibility testing is a way that we can make sure that the site works well, not just on one browser on one device, but on lots of browsers on lots of devices, particularly mobile devices. So we've already talked about some websites that we can use to do this. There's the HTML validator, which you should be using on all your labs at html5.validator.nu. Another website that's really useful is called browsershots.com. What this does is really neat. It's a server that has a whole bunch of different web browsers on it. And you give it a URL, and it will pull up your URL in all of those browsers on all of those virtual machines, and it will take screenshots of them and make them available so that you can see what your website looks like on all of those different browsers. That's a really neat thing. But of course, there's no substitute for manual testing. You should, of course, visit every page that you create. You should run your scripts and do your logins and things so that you can test that every feature is working on more than one browser. So here's some things to test. Make sure that form handling and navigation work properly. Some browsers do form navigation differently than others. Maybe when you hit Tab, it goes to one order in Chrome, but it goes to a different order in Internet Explorer. Check that pop-ups, cookies, history, and cache settings work. Check that your CAPTCHAs and privacy protections are functioning. Check whether your website works in the presence of different antivirus and malware filters like SmartScreen. Check whether your website works if it's accessed through a proxy server or using page prediction. Check that your website, if it requires add-ons and extensions, that those work in different browsers. This is especially important if you use JavaScript or Flash. Make sure that JavaScript works in every browser, not just one. And finally, check that protected media licensing or DRM content still loads. There's videos and things like that. Usability testing tests whether the website is easy to navigate and use. So is navigation consistent and intuitive? Do you have the same nav bar on every page? If you have help messages, are they actually helpful? Clicking on a button that just says button doesn't really help me. Is the flow of the website consistent? Does it make sense? Is it easy to navigate the flow of the website? Are style policies consistently applied across the site? How is the data arranged? Does it make sense? Also check that multimedia content loads properly. And I emphasized this before, but one of the things that's really important is the content accessible not just to you, but to users with disabilities, colorblind users, users using a screen reader. And finally, it's important to do quality assurance testing. Do you have a polished, professional-looking website? Are there any broken links? That's a big turnoff to users. Is the content out of date? Is there missing content? Are the pages missing key metadata? I mentioned those bots that search your web page looking for keywords to put on the website. There are tags you can embed in your page that don't show up to the user, but help the bot find what it's looking for. For instance, you can put keywords into a meta tag. So make sure that you've got those on every page. It might also be important legally. If you get sued or if you're hacked and you need to give evidence in a case, it can be really helpful if you have comments or something in your page that identify the author of the web page and make sure that you've got any copyright notices and those kinds of things in the code. make sure your website is legally and professionally compliant. If you're handling credit card data, you need to follow the PCI, the Personal Cardholder Information Laws. You also, if you're handling privacy data, you need to follow Graham-Leach-Bliley Act, and if it's medical data, the HIPAA laws. So make sure that you're legally and professionally compliant. There's a standard called WCAG2 that we talked about a couple lectures back. Make sure you're following the accessibility standards. The Americans with Disabilities Act requires your website to be WCAG2 compliant. Check for copyright violations. Make sure that you're not using material that belongs to somebody else without their permission. So in summary, site administration and maintenance are really key aspects of designing a successful website. Some of the tasks that we talked about are setting up and configuring the software, analyzing server logs, performing regular backups, managing the site's public availability, its IP address and its domain name, and also performing regular testing. Good luck with your labs. I hope you're enjoying the course.